Hello everyone, this is M. Pawan Kumar from Triple E branch first year, second year, and my roll number is 21951802115, and my subject is network analysis, and my topic is about a note on transfer and driving point function of iterated ladder network. So let us enter into the topic. So can My topic is about mainly a note on the transfer and driving point function of iterated ladder networks. So let us enter into the topic. So driving point function and transferring function. So for a given network, the ratio of Laplace transformation of the source voltage and source current is called driving point function. It is ratio of the source voltage to the source current. It is called driving point impedance function denoted as ZS, while if its ratio of source current to the source voltage, it is called driving point admittance function denoted by Y. So the driving point impedance function is noted, but the input impedance of the network is viewed as through the input terminal, as Y is the reciprocal of Z. These functions are called impedance function. While define these functions, all are initial conditions as assumed 0, and there should not be any impedance voltage or current source presence. So the driving point of impedance function is nothing but the input impedance of network as viewed through the input terminal, as Y is the reciprocal of the Z. These functions are called impedance function. So the driving point of the impedance function is nothing but the impedance of the electromagnetic field as viewed through the input terminal, as Y is the reciprocal of Z is. These are functions called impedance function. While define these functions, all initial conditions as assume 0, and they should not be impedance voltage or current source presence. The impedance function is always a ratio of 2 points. So the impedance function is always a ratio of two separated volumes. Driving point is equal to, so this was defined as driving points. So driving point function is equal to P of S by Q of S. These are the 2 points of driving points. Function can be represented as, so where P of S is numerator polynomial and Q of S is denominator polynomial in S. So the impedance function is always ratio of 2 points. So where the 2 points are P of S and Q of S, where P of S is numerator polynomial. So we just now see when the driving point function is equal to P of S by Q of S. So where P of S is numerator polynomial and Q of S is denominator polynomial in S. Necessary condition for driving point function after cancelling the common factors. So necessary conditions of driving point function. So these are the points which are necessary. After cancelling the common factors in the numerator polynomial P of S and the denominator polynomial Q of S, the necessary condition for the driving point function are as follows. The coefficients of the numerator polynomial P of S and the denominator polynomial must be real and positive. So here we read, if you see the points, 2 points, after cancelling the common factor in the numerator polynomial P of S and denominator polynomial Q of S, the necessary condition of the driving points and functions are as follows. The coefficients of the numerator polynomial or the denominator polynomial must be real and positive. If poles and zeros are imaginary, then such poles and zeros must be conjugated. So if the poles and zeros are imaginary, then such poles and zeros are must be conjugated. The real part of all the poles and zeros must be negative or zero, and if the real parts of zero, then the poles or zero must be simple. There should be any missing term between the highest and lowest degree in the polynomials. So P of s and Q of s are used unless and all the even or the odd terms are missing. The degree of the polynomial in numerator and the denominator should be either 0 or 1. The terms of the lowest degree in P of s and Q of s may differ in the degree at the most by 1. So let us see the transfer function. So the main head is the transfer function. The ratio of the Laplace transformation of the network parameters at one port to the Laplace transformation of a network parameter at the other port and vice versa are called transfer function. This function may be voltage ratio functions, current ratio function. Such function may also represent a transfer impedance or transfer admittance of the network. These are also determined under the same assumptions as all initial conditions are 0 and non-dependent current or voltage source is the presence in the network. The transfer function are also ratio of two separated polynomials in S. Necessary condition for transfer function. These conditions are necessary for transfer functions. After cancelling the common factors in the polynomials P of s and Q of s, the necessary condition for the transferring are following functions. So the coefficients of the P of s and Q of s must be real and positive. The complex and imaginary poles are 0 must be conjugated. The real part of pole must be negative or 0. So the real part of the pole must be negative or 0, and if it is 0, the pole must be simple and including origin. There should be any missing term between the highest and lowest degree of Q of s unless all the even or odd terms are missing. So the polynomial P of s may be negative term or even some missing term between the highest and lowest degree. The degree of polynomial P of s may be the small as 0 impedance of a degree of the polynomial of Q of s. So the fraction order of impedance model of ladder network are using the minimic lung tissue, and we know the lead to fraction order Laplace operator model that we have transfer function denoting the fraction order impedance model. These models can be modern part at micro or macro scale, tissue structure or multiple scale properties, in which case there are multiple terms in fractions order terms. The literally inverse of such model applied to the various biological tissues. So the real part of the poles must be negative or 0, and if it is in the 0, the poles must be sample origins. So this should be any missing term between the lowest degree and unless even or odd terms are missing. So this is about the whole topic of network analysis. Thank you.